Hi, so in this video we're going to use what we did in the previous one with Excel, and we are going to put this data into Logger Pro, plot it, and then we're going to try to figure out what the best fit is for that data. Now as you can see, I have Logger Pro open here and I have Excel open here. So the first thing that I need to figure out is what goes in where. So what goes in the x-axis, what goes in the y-axis. Now what goes in the x-axis is always the independent variable, which is what we were changing. In this case, we were changing the number of coils. So that goes here. Another way to remember this is that in the y-axis, we're going to put the thing that we measured 5 times, where we have a random error. So in this case, y goes with the average time. Now I'm going to do this step by step, even though, of course, you could just select the whole thing and just paste it in there. So basically, you just take this column, hit Control C, go over here, hit Control V, and there you go, here are the points. Then we do the same with the average time, Control C, then Control V, and now we can see the points. Now straight away I can see that even though my hypothesis was that this was going to follow a straight line, this does not follow a straight line. In fact, this seems to follow a curve that looks like a square root. However, what I'm going to do is I'm still going to plot the straight line just so that I can print it, put it in my lab report, and then say, well, look, this is not a good fit because of this, this, and this, and that's why I'm going to try a different fit. And then what I will have to do is to justify that other fit that I'm trying and give some kind of explanation for it. So, okay, well, before I start looking into fitting this data, I still need the error bars. So what I need to do is I'm going to extend this by clicking here, and I'm going to add a new column here. In order to do that, we go to data, we say new manual column, and then you just give it whatever name you want that's going to help you. So in this case, I'll just say error y, and the short name will be EY, and done. And here's our new column. So here I need to paste my random error from before. So Control C, Control V, and you'll see that nothing happens. And nothing happens because Logger Pro doesn't know that this is the error in Y. I need to tell it. In order to do this, I just right click on column Y, I go to column options and choose dataset Y. Then I go to options, error bar calculations, and I say use column, and I just use the one with the error. Done. And now I look at my data and I can see that I'm in trouble because my error bars are tiny. And there is no way that my best fit line is going to go through all of them. And that's okay. That's okay, because then this just means that, well, maybe my fit is not good, maybe my hypothesis was not true, or maybe I just underestimated my error and I need to find out why my error is so small when it should be much larger. Okay, so the first thing that I'm going to do, even though I already told you I know this is not going to work, is to try a linear fit. In order to do this, I go to this little icon that says R. If you put your mouse on it, it will say linear fit, and I just click on it and it will just do a linear fit. Now I need to look at several things. The first thing that I look at is that this thing, it does not go through most of the error bars. So not this one, this one, this one, or this one, or this one. So that's a bad sign. That's a sign that our fit is not good. Now the second sign that my fit is not good is that if I look at here where it says correlation, I don't know if you can read this, but it says 0.987. Anything below 0.99 is a bad correlation. And I mean, you don't have to really look at the correlation. You can just see that these points clearly do not follow a line. So this is a bad fit. And I need to find a different fit. Now there's several ways that I can do this. And I'm going to do this in the way that's easiest to analyze. So by looking at these points, and this is something that you will just learn, I guess, with experience, I can see that they keep getting, you know, as X keeps getting bigger, Y keeps getting bigger, but less and less and less and less. So this is less than a line. It's not a quadratic, which would do something like this. It's kind of the opposite of a quadratic, right? It does something like that. And that tells me that very likely the relationship between this and this is that Y goes with the square root of X. Okay, good. So if Y goes with the square root of X, how can I test this out? Well, I could just do a fit with a square root, but this is very hard to analyze. So instead of this, I'm going to again linearize my graph. How do I do this? Well, instead of plotting y against x, I'm just going to plot y against the square root of x, and then I should have a line. So let's do this. In order to do this, all I need to do is to take this and turn it into the square root. Now again, you don't need to do this by hand. The beauty of Excel is that it does this for you. So I go to a new column and I just say equals square root sqrt of a2, close brackets. And there you go. Here's my square root. Control C, Control V, and here I have all my square roots. So now all I need to do is copy this and paste it into X. And you see that the whole thing changes. Now the first thing that I'm going to do is eliminate my line of best fit from before. And the second thing is I'm going to press Control J, and this is what that does. It just fits the screen to a better size. And now I can just go and do my linear fit. So again, I go to this little icon and I click on linear fit. And now we can see that things are better. It is true that this still does not go through most of the error lines, but this is much more consistent. This really does look like a line, first. And second, if I look at the correlation, I have 0.9951, which is way higher than before. This means that this line fits these points much better than the previous one. So what I would do is I would, again, copy this graph, paste it on my lab report and say, well, look, now I tried this fit and this fits much better. Sometimes you will have to try 4 or 5 different fits, and that's fine. And then until you find one that seems the best. And sometimes you won't even find one that's the best. You will find a couple that seem pretty good. And again, that's also fine, as long as you have some kind of explanation for why that is the case. So what I would do now is I would paste this into my lab report, and I would try to find some kind of explanation of why y seems to go with the square root of x and not with x. And this could be many things, you know. So for example, as one of the things gets bigger, the other one gets less and less big because of whatever diminishing returns. This could happen, for example, with a spring, where there's a point where it's so stretched that you need to do a lot more force to stretch it enough, and so on. Now, one more problem that I have here is that my error bars are really tiny. So I need to do something about that. So for example, now I'm just going to try and change these error bars to a value that looks more reasonable. And I'm going to try 0.5, see what happens. So I'm just going to substitute everything for 0.5 and see how these things looks. Okay. And 0.5. And now I look at my graph and the fit looks much better. There are still a few points that are outside the line, but by very, very little. So for example, 0.7 error would account for all of this. Now, I can't just change my errors and be like, oh, there you go. I changed my errors because otherwise it didn't fit. I need to have some reason why this is so. So now I just found out that if I make this error bigger, things look a lot neater. But now I need to go back to my lab report and say, okay, well, why did I underestimate the error so much? Was there some source of error that I didn't take into account? And if there is, which one was it? How could I avoid it in the future? And so on and so on. So again, you're not allowed to just do this and be like, oh, there you go. You need to give reasons for everything that you do. In this case, I don't know the reasons because I didn't do this lab. But it is very likely with all the equipment that you use that there's always one main source of errors that you're not taking into account. The only thing that I want to say before we finish is that, of course, you need to, like here I just had X and Y, but you are going to have to change this and give it a proper title. So in your title, you should say the variable, and you should also say the units for both of them. That's the only way to get a complete in the IB, and it's also common sense. We need to know what you're plotting, and if you don't say the units, it's like saying nothing. If they say I weigh 60, you weigh 60 what? You weigh 60 grams, 60 kilograms, 60 tons. As you can see, the answer is very, very different depending on the unit. So you need to always say what you're plotting and the units in which you're plotting it. again, when you're experimenting, that's not so important, but when you're putting in your lab, it is. Okay, well, that's all from me. And of course, if you have doubts, please just leave a comment and I'll try to get back to you as soon as I can. Thank you.